Hey everybody, we're in the end game finally. The end of our Uber lecture marathon. We're going to take a look at confounding. What? You are confounded by the term confounding? You don't know what it means? Well, let's take a look. So, let's hypothesize something. Let's say that we have some data that suggests that maybe shoe size and literacy are related. In fact, it looks like in this data that after a little bit of exploration, maybe there's a possibility of a relationship that we could even put a regression on, that people with bigger shoe sizes are more likely to be literate than people with smaller shoe sizes. Interesting. Oops. Well, maybe that's not such an interesting thing after all. So what has happened here? Well, it turns out that there's a confounder in play. All right? That confounder is age. Age is the thing which is responsible for both the shoe size and the literacy. So we were thinking that maybe there was a relationship where shoe size was driving the literacy. But it turns out that no, that is not the case. It's just that the thing that created both shoe size and literacy measurements was how old somebody was. So this is a confound, or sometimes we call it a confounder. Okay? I apologize for my terrible handwriting. So anytime we have something responsible for both the items we're measuring, that is a confounder, or at least potentially responsible. So what would this look like in a more interesting case, something that actually crops up? Well, here's another little quiz yourself inside your head, because I'm not doing any forms today. You notice that there is an increase in the crime rate at the same time that we see spikes in the sales of popsicles and ice cream. Now, what is going on here? What do you think? Is there a confounder potentially in play? What would be the problem? So we see in our data that we can measure, we see dollars in popsicle sales, and we see violent crime rate. And so we're wondering, is this true? Man, my drawing skills are just going in the toilet right now. So, is this relationship a true one? Or is there potentially a confounder? If there is a confounder, which one of these selections, A, B, C, D, E, would it be? Okay, somebody? Anybody? Yeah, back row, the one with the cool shoes. All right. I'm going to say that I'm not sure why you think that a change in popsicle price is the responsibility, is changing the crime rate, right? So changes in popsicle prices, option D, that can certainly change popsicle sales, right? That makes total sense. But what we're after with a confounder is that something is responsible for both the change in popsicle sales and the change in crime rate. And I just don't see how changes in popsicle prices are responsible for crime rate. So somebody else. Yes, you, front row. Yes, temperature, right? When the temperature goes up, you are going to see increased sales of hot weather things like popsicles and ice cream. It's also a relatively well-known fact that the crime rate spikes when it gets really hot. So, like Chicago's shooting problem that it rather notoriously has. The number of shootings in Chicago go way, way up on hot summer days and way, way down on stormy winter days. When it's cold outside, people can't go outside and find each other and shoot each other, right? And when it's hot outside, maybe people's tempers are a little bit more on edge. That's at least one of the hypotheses for why, but it's very clear that there is a temperature relationship to violent crime. So in the end, the temperature is actually driving both these things, and there's no direct relationship between popsicles and crime. All right. So ignoring confounders will lead you to draw incorrect conclusions. All right. Maybe you can plan ahead and include confounders in your model, and that way you can account for their role. So this is certainly something, oops, forgot I had my video off. This is certainly something that people will do. If you know that there's a potential confound, you can include it in the model you're building. Now, the exact way you do that is a little bit beyond the scope of this course, but if you know that there's a confound which is going to get in your way, you can eliminate it by setting up your model in the right way to estimate the size of the confound and subtract that out, and then just leave any true relationship. So the idea in that circumstance, oops, okay, go back. So if you're going to, in that kind of case, what you're implicitly saying is that I have A and B, my observable variables, and I think there might be some relationship of A and B, but I know there's a confound, and I know that that confound partially drives the differences, but maybe it doesn't fully drive the differences. So in my model, I can allow the confound to be regressed as part of the model. And once I have numbers on how much these effects are right here, I can take what I observe to be the correlation between A and B, and I can subtract out what's due to the confound and just find what's a direct effect. Okay? Again, that's more to make you aware of the fact that this kind of thing will crop up later when you get more and more statistics and machine learning under your belt. We're not in any way asking you to remember this. Okay? So let's do another example of confounds that you might find. So here's a paper about a kind of surgery for people that have a back fracture. Okay? Vertebroplasty. I have no idea what that is. But it's a way to treat somebody who has a fractured spine. Now, you can use this kind of surgery, or you can just kind of keep them comfortable and keep them from doing anything ridiculous and let the fractured spine heal on its own, right? Obviously, as long as you don't have a severed spinal cord, it's just a broken bone and nothing else. So, the question is, does this surgery help out? Or should we just let our patients heal up by themselves? All right, so we check out how many of these patients end up with getting a secondary fracture down the line, right? So obviously it's bad if somebody with a fractured spine has another fracture. Indicates that the healing process was not complete. Okay? So if you look at this, there are 30 out of 200 people who underwent the surgery who got another fracture, a second fracture. Only 15 of the people who got conservative care got another fracture. So that means that they are at twice the risk. So the people who got the surgery are twice as risky for them as just laying in bed and hoping it'll all heal. Whoa, that seems like that's a terrible, terrible thing. I don't think I want to get vertebroplasty if I have a spinal fracture. But wait, are there any confounds? Right? So let's take a look. We have a sample of patients. We had 200 patients who went through the surgery and 200 who got conservative care. Are they the same kinds of patients, or is there a difference? Let's do the descriptive statistics. All right. So it looks like their ages are pretty good. The weight of the two sets of patients is very similar, but this is wacky, right? There's certainly like 5 times, maybe almost 10 times as many patients who are smokers that were in the group that got the surgery. Damn, somebody did not make a really good randomized sample. It looks like this sample was not well balanced. Well, maybe the smoking status has to do with the likelihood of a subsequent fracture. Because it's relatively well known that smoking affects your body in many different ways, and it includes actually inhibiting various kinds of immune system and healing responses. So, if smoking status varies like this, maybe what we should do is take a look at those people we had who were smokers and non-smokers in both groups and compare apples and apples and oranges and oranges. This is called stratification, where what we do is we take, in our vertebroplasty group, we had a lot of smokers, but we also must have had some non-smokers. Okay? Well, it turns out that we had 7 non-smokers in the vertebroplasty group, and we had 23 smokers. In the conservative care group, we had 3 smokers and 12 non-smokers. All right, let's compare apples and apples. So we're going to compare those two against each other, and that leads to a 1.1 risk ratio, right? So 19% versus 21%. So they're very similar risk ratios. And so there's really no difference once we correct for only comparing smokers against each other and only comparing non-smokers against each other. We get very similar risk ratios. It looks like maybe, like this number is greater than 1, but look at this confidence interval. The confidence interval goes from less than 1 to greater than 1. What's a confidence interval? Well, we covered that way back when, remember? A confidence interval says, right, we know that if we got brand new data with new patients, we would likely get slightly different results. And if we got slightly different results, that risk ratio might be slightly different. Well, if we did the same experiment 100 times, then we would expect to get results with a risk ratio in between 0.4 to 3.3. We would expect to get that 95 out of 100 trials if we did this over and over and over again with another 200 patients. Oh, look, my camera's still crap and still turning off after a relatively short time. All right, well, at any rate, you're going to have to finish without my face. So, the confidence interval tells us that we think that the data could be less than 1 risk ratio. It could be that conservative is actually more dangerous than vertebroplasty group. We don't know. We are not able with this data to tell if there is a difference between vertebroplasty. With this data and this analysis, what we're finding once we correct for the confounding smoking status, once we've corrected away and compared smokers with smokers and non-smokers with non-smokers, we don't see any difference between the vertebroplasty treatment and the conservative just let them heal up treatment. Okay? So either there is no difference, the surgery doesn't help or hurt, or there is a difference, but we need many, many more samples to be able to see it. All right, so the risks are now similar. So that is really what I wanted to show you with confounds. Realize that every time you ask yourself about a relationship between x and y's, between variable 1 and variable 2, you should also ask yourself, is there any potential that there could be some other thing, a third thing, which is a confound, which is confounding these two? And if I can imagine that such a thing is the case, can I establish that it is true and include it in my analysis? All right, so that's all, folks. Thank you so much for slogging through 2 full days of lecture in one go with me. I hope never to have to do this again, but then again, I hope we never have to go through an election like that or a set of camera failures like this. All right, have fun. Bye.